as you can tell, I finally got the cold and finally got a decent share of it. My kids have had it, my wife's had it, grandchildren have had it, bunches of you have had it. But now I'm sucking on cough drops and trying to get enough voice to do our class. I have help and volunteers, so at some point I might call some people up. I thought I would start by going over the model of the firm, and I'll come back to, or maybe we'll finish the stated preferences. So if you don't have one, there are a few extras. You can come get it. We're most of the way down the page where it says stated preference. The key to doing a stated preference survey is to convince, it's the same as last time, so if you have it. The key is to convince the respondent that it's a real project and there's something else they can do with their money. And you do this to try to get a real answer out of them and have them not instead just say, well, it's all made up, I can do whatever I want, $1 billion. So you're trying to get rid of those kind of responses. And I list this set of steps on the sheet that's usually done. The easiest format is a referendum. And the way you do a referendum is you have a project, subsidizing reindeer chow because you want more reindeer, and want to increase the amount of reindeer ranching in northern Sweden. And so you ask people, would you vote for this project? So the key thing you're going to do at the end is you're going to say to some people, if it costs you $10 a year, would you be in favor of increasing the reindeer? Or yes, no. To others you'll say 20, others you'll say 30. And so now you have the percent that say yes or no as a function of the price. And that's what gets you your demand curve. You can also do this open-ended. How much would you be willing to pay? But there you have to worry that what happens if even one person says, 6.02 times 10 to the $26, 10 to the 23rd, all right. It's just really not going to help. What are you going to do? Oh, it's a protest vote, I'll throw it out. Why is that legit? So that's why the referendum works better. You can't get people giving obscene answers. Problems with this sort of stuff are people can think it's hypothetical, and that's going to lead them to just give random answers or to lie. Other problems are, if you did a lot of them, you did a lot of different animals. You discover people in the old days used to give you an answer of about $40. How much would you be willing to pay to save the spotted owl? 40. How much for the snail darter? 40. If you multiply by all the animals there are, you end up with really large numbers. And so is there something wrong here? Are they answering all that they'd be willing to spend to save the whole environment when you ask the question about the owl? Some think yes, some think no. As I would read the evidence, basically no. People do very reasonable things. If you ask them about lakes that are nearby for which they have use value, they give you a high answer. You ask them about ones further away, they give you a low answer. And so you would not want to take the number of lakes in like Minnesota and multiply that by what someone would pay to save their nearest lake. So I think a lot of that problem is made up. Conjoint analysis. This is the example where you have 3 gardens or 4 gardens, and each of the gardens is made up of a finite number of attributes. So they have color, water use, and cost. And you ask which garden would you like, obviously you can find out the demand for gardens. But if you knew the demand for gardens, then you could unravel that and find out what's the demand for the underlying attributes, color, etc. So the idea of a conjoint analysis is to be able to have someone choose among alternatives, and by choosing among alternatives, reveal their value for the underlying attributes like color. Why would you do that? Well, I want people to have native gardens because they use less water. So suppose they value color a lot. Well, then I'm going to run out and I'm going to look for colorful native plants, right? That's what would make sense. So it's very valuable in how you're trying to design a project. We usually ask people questions about willingness to pay. And what we want to know, or what we as a teacher want to know, is are they revealing CV or EV? And basically you have to read each question and see whether or not they end up with changed utility or unchanged utility. So let's see. How much would you be willing to pay to have me not shoot wolves? All right. So when you say $40, what have you found? So make the argument. So either the wolves die, change utility, right? Or you pay the bribe, change utility. 2 ways to change utility EV. Right? That's how you think about them. How much would you be willing to pay for a new ski area? CV or EV? Right? Because you get the new ski area, but then you have to pay up, and you end up same utility, no change in utility, compensated. So that's how you answer those if they should appear. Now let's go and do the theory of the firm. If I were feeling better, I would do it hopping on one leg. You already saw my attempt at that, but today I would just fall over. Nothing good would happen. Could you favor make this go away? Take this and make it go away. Stand up, take this thing and shove it somewhere. So I don't walk into it. If you need help, you can get help. Thank you. Put it way over to the side or something. Yeah. Don't be gentle. The times won't be bad. Thank you so much. Because otherwise I'm going to bang into it. See? You did something useful today. She got wheels. In case you're wondering, if it were up to me, a lot of this stuff would disappear. First thing we want to do is we want to argue that a price-taking firm will choose quantity so that price equals marginal cost. Or they will make nothing, but we won't get to the make nothing part yet. The easiest way to do this is draw a diagram like this and consider 3 cases because there are only 3. If Q is over there, if the firm makes 1 more unit, what do they get for it? It's not a trick question. It's very easy. No, not the profit per unit. I sell you a candy bar. You pay me. It's price, right? Yeah? This is too easy. Okay? What does it cost you to make the next candy bar? What does it cost to make the next unit of the good? Marginal cost. So Price is better, bigger than marginal cost. Do I have extra money left in my pocket? Yes. Do my profits go up? Yes. So is that optimal? No. Right? There can't be an optimal approach. Profits go up in that direction. What about here? Someone talk through with me backwards. So you produce one less, and that would give you more money left in your pocket. Yep. And so what's the only other alternative? Price. Okay. And what do firms choose? Price-taking firms choose what? Quantity. Can they choose price? No. Why? Because you assumed it away. Right? So you take another course, they'll undoubtedly do monopolies and monopolistic competition, and they'll produce for you into cases where price and quantity both move. But we stayed simple. Yeah. Yeah. Okay. Yep. So if price is less than the minimum point on average variable cost, then profits are minus fixed cost plus price minus average variable cost times quantity. But this number, P, is less than APC. Yeah? So this term is negative. So profits are less than minus fixed costs. So producing 0 is better. Yeah? So one line proof. So that's the supply curve. Yep. Price minus average cost times quantity, profits. Look at how this squares off here. Look what you can see under it. Yeah. So again, if you're unsure, start with price. One, get your price. Go over to MC. Go down to quantity. Then your box is on this side P minus AC, and on that side quantity. And that's just what the box is. Average cost up to Q. Yeah, better Q. Even better? Okay. So now we have one more piece, which is number of firms. Firms enter. Firms exit. So this object is the short-run supply curve if there were n firms. How did I make it? This is the supply curve for a single firm. Take the distance, that's the supply, multiply by the number of firms. 1, 2, 3, 4, n, because I had n of them. Yeah. Do the same thing at this magic point. What's magic about this? What are profits? What are profits here? When price equals average cost? 0. Okay, so it's magic. 1, 2, 3, 4, 5, n, and do it at some high price and connect them up. Now, to set it in motion, I draw the demand curve. I'll draw it high up. Can this be a long-run equilibrium? It's a short-run equilibrium with a high price. Right? You fix the number of firms at n, and that's the short run. Do they make money? Will others want to come and join them? What will happen when others come and join them? N will become n plus something, right? Which will eventually get us out here. And so in the long run, profits are always 0. Well, let's take this. So if there's an original average cost curve and a new average cost curve because there's some kind of regulation, and the new costs are higher. Here's the two long-run supply curves. Who pays the entirety of the cost? Just like your first problem said. Right? Have a supply curve. Supply curve is completely flat. It shifts up. What happens? Does the price go up by the same as the supply curve shifts? Does it all pass through to the consumer? Yeah. Right? So in this model, if you think that many firms can enter, and you're going to regulate the firm for whatever reason, no matter how good, what you're guaranteed is that it'll pass through to the consumer. All of it. So you make the producer pay for his pollution. The producer will pass 100% of it on. You like that, do you? No, but I think it's the leading case. Yes. So if you have things that break it up, like the number of firms can't change, yeah, all kinds of things that break it up, then you can get other answers. But the leading case really is in a manufactured good. If I go to the producers of spray paint and I say there has to be less VOCs in your paint, and it costs 10% more to make the paint, you really will see the price go up by about 10%. Yeah? And they make zero profits. They made zero profits before. What about a case where they do make profits? In residential real estate, right? Now it doesn't have the same thing at all. Now they're making positive profits. Maybe it comes out of their profits. We don't have a nice model here for it, but that'd be a counterexample. For spray paint, this would be it. Now let's go dig under this and look about how you might change pollution. You notice right here, if I make the firms pay, one of the things that happens is that the quantity. Right? So a good thing is the quantity of the pollutant goes down. You get the right signals. No more spray painting. Too expensive. Find a new way to do your tagging. Yeah? So that's a good thing for an environmentalist. But let's go look under this a bit. Two inputs, one of which we're going to label pollution. But you can think of it as garbage collection services. Makes more sense that way. And all other inputs. So, other input. So as you use up more clean air, you need less other goods to make your output. If clean air were absolutely free, you'll just keep coming out this way, and that would be the end of it. I'm going to assume that it costs something to dirty up the air. You have to push the fumes out or something, so I can keep it as very standard analysis. Isocost, all bundles that cost the same. Isoquant, all bundles that produce the same output. Standard problem. What is the way to produce the output on this isoquant with the prices embodied in the isocost line? The prices are just the slope. Right? Isocost, as usual. Right? So the slope line is here. And that's all you're told. You're told P1 over P2. So you could create a family of lines with the same slope and find the one that's tangent. How do you want the one that's tangent? The ones that are down here don't make the output. The ones that are up here cost too much. So you want the tangent one. Same argument as for the budget line for consumer. Now, if I wanted this firm to be cleaner, there are two ways to make it cleaner. One way is to have it make less output, and the other way is to have the output be cleaner per unit. Sorry, the product be cleaner, right? Less pollution per unit output. How do I get them to make less pollution per unit output? I need them to go this way. It's not cube, sorry, that's air. Use up less air. There are two ways to do that. Way one is